Okay, and we're on 9.2. Why are we not starting with 9.1?
Because
9.1 is harder, and we thought we'd ease you into the chapter. Okay? So, we're going to start off. Let me write period 2 on here. I'm going to go ahead and put the homework assignment at the top. I would suggest you do the same. Page 375. Again, if you're using the online version, it's not going to say 375. It'll say something else. But go to the homework problems. You're going to do 2 through 13 and 21. I have Google Classroom set up. I don't know if I told you this or not, but I have Google Classroom set up that it will allow you to turn it until 11:59 p.m. tomorrow. Past that, it will say, you're late. No good.
Is that doing that for the other ones too?
I changed the other ones so that you can't turn them in anymore. So if you were absent and you've already worked something out with me, then you can hand me your paper as like a hard copy. But I don't want to just leave all the assignments open on Google Classroom for anybody to turn in whenever, because that gets very chaotic. Yes?
Can I hand you the hard copy on? Because I forgot what I did online.
Can we address it after class?
Huh?
Can we address it after class? Thank you. Okay. So, multiplying and dividing rational expressions. What is a rational expression?
fraction.
It's a fraction. The Franken definition is that it's a really ugly fraction. Okay? So, like for example, if I looked right here, that guy right there, hideously ugly fraction. Yeah?
Yeah.
Very ugly. That's a rational expression. Okay? We're going to be multiplying and dividing. Since we're going to be multiplying and dividing and these rational expressions are fractions, then reducing or simplifying is going to be a very important part of what we do. Because whenever you have fractions, you always have to reduce. Drives me nuts when people come up and ask me, do I have to reduce this answer? Yes. The answer is always yes. You never leave a fraction unreduced. Ever, ever, ever. Okay? So, let's start off with a problem that you would have had in 5th grade. Just like this. How do we multiply fractions? We multiply straight across. Top times top gets you your new top. Bottom times bottom gets you your new bottom. Now, you do have an option before you multiply. You can do some cross-canceling if you want to. If I wanted to cross-cancel, that means what I'm going to be multiplying is going to be smaller and therefore hopefully easier to reduce at the end. So, if I wanted to do some cross-canceling, I think 12 and 4 are both divisible by 4, right? What does that make the 12 become?
3.
And the 4 becomes a 1. And then on the other crossways, I have 9 and 15. Those are both divisible by
3.
That gives me 3 and 5. So now if I multiply straight across, 3 times 5 is 15. 3 times 1 is 3. And 15 over 3 is 5. So multiplying fractions, you can cross-cancel. I chose to cross-cancel here because 12 times 15 is a pretty large number that I might not know how it reduces. When we get to the x's in the fractions, we're not going to be cross-canceling. Okay? You can, once you get pretty fluent with this, you can go ahead and cross-cancel, but we're not going to do that right now. Let's see. On these notes, if you'll notice, we have multiplication on the left, multiplication, multiplication. On the right side, we have division, division, and at the bottom we have division. So I'm going to start off with multiplication. Okay? So, the most important thing on these notes right here is right here. Factor the top and the bottom first. Okay? Factor the top and the bottom first. Okay, so if I look at this, I have 4 places to check for factoring. I have the top of the left, bottom of the left, top of the right, bottom of the right. So if I look at the top of the left, can I factor this? Yes, I can take out a 4. What's left inside? X plus 3. That's a pretty simple type of factoring, right? You're going to see that kind of factoring a lot in these problems. We don't get into the super, super complex factoring very much, but we do get a lot of factoring like this. Can I factor 3x squared? No. A monomial we cannot factor. Can I factor 5xy?
No.
Nope, because it's a monomial. And then 4y cubed? Nope, because it's a monomial. Now, I should have said this before I did this problem, but I didn't. What we're looking for eventually is things that we can cancel out, so things that match on the top to the bottom. Now, a lot of people will look here and say, oh, there's an x on the top and an x on the bottom. I want to cancel those out. Well, you can't. Because if I have a plus sign or a minus sign that's not in a parentheses, then I have not factored. And if I have not factored, I cannot cancel. Okay?
You said that's not in a parentheses?
That's not in a parentheses. So up here, that's not in parentheses, is it?
No.
It hasn't been factored, so I can't cancel. I can't cancel a part of that with something else. Now, can we cancel top to top?
Yeah.
No. We can only cancel top to bottom. Just like with our cross canceling up here, it was the top of one and the bottom of the other. I could actually have canceled these 3's and turned them into 1's, but it always has to be a top with a bottom. It can't be a top with a top. So, here's my trick for multiplying fractions. You ready? Wait for it. This is going to be very difficult. Boom. Okay?
No way.
Yeah. Because by not writing anything between these two things, guess what that means? Multiplication. And by not writing anything between these two, guess what? It's multiplication. So now I can start canceling things from the top and to the bottom. Now, rules for canceling. You cannot cancel something in parentheses with something not in parentheses. You can only cancel parentheses with other parentheses that match them exactly, or not in parentheses with not in parentheses. All right? So I see a 4 that's not in parentheses. I'm going to cancel that with this 4 that's not in parentheses. Do you see any other numbers not in parentheses that I can cancel? I see a 5 and a 3, but they don't reduce it or cancel it all, right? So I'm going to say 5 is still on the top. There's nothing I can do with that guy. 3 is still on the bottom. Now, I have x and I have x squared. Can those cancel?
Yes.
Because technically that means I have 1x on top and 2 on the bottom. So if I cancel, I'm left with 1 on the bottom. So, done with the x's. Y's, I have 1 on top and 3 on the bottom. So if those cancel, what's left on the bottom? Y squared is left on the bottom. Got my 5 and my 3. What else is left? X plus 3 on the top. I couldn't touch that one. Now, do I distribute the 5 to the x and then to the 3? No, not this chapter. I want you to leave things in factored form. That shows me that you've checked everything that could possibly cancel. Okay? Questions there?
So everything on top basically stays on top, unless it gets canceled out.
Uh-huh. And everything on bottom stays on bottom unless it gets canceled out.
How'd you get the 3x? Never mind. The x. Never mind.
Got it?
Yes.
Okay. All right, let's look at the next one. Again, 4 places. Actually, you know what? Before I go on to the next one, I want to talk about something called excluded values. Excluded values. Whenever we deal with fractions, we have these things called excluded values. And what does that mean? Well, let me get a little scrap piece of paper here real quick. Now, when we first learned fractions, we learned that that fraction right there means you have a pizza, you cut it into 4 pieces, and you ate one of them. That's what that meant, right? If you had a problem like this, that meant that you had a pizza, you cut it into 7 pieces, and you ate 2 of them, right? You can totally do this. You can cut a pizza into 8 pieces and eat none of them, right? The problem is when we have that. How do you cut a pizza into 0 pieces? If you don't cut it, you have 1 piece still, right? You have 1 giant piece. You can't make this situation happen. You can make this situation happen, but you can't make this one happen. So we have an issue when we have a 0 on the bottom. So, if I have this problem, there is the potential that there could be a 0 on the bottom. Because I have not told you what x equals. If I told you x equals 3 and y equals 5, go ahead and plug it in and solve it. You could do that, right? But there would be a problem if I said plug in x equals 0, because what would happen?
It'd be 0.
You would end up with 0 on the bottom, because 0 times anything would give me 0. There would also be a problem if I told you that y equaled 0. Correct? Because 0 squared is 0, times anything is 0. So we have an issue there. We can't have x and y equaling 0 because it gives us that impossible pizza situation. So my excluded values, I put a little line through the equal sign, and that means those are the two values that x cannot equal or y cannot equal, because they will make that fraction what we call undefined. Okay? Questions there? We'll keep talking about that as we go on. All right. This problem right here, can I factor 2x plus 2? Yes, I can take a 2 out. What would be left inside? X plus 1. On the bottom, x plus 3. Can't factor that, can I? So, if I can't factor it, I don't want to leave a plus or a minus sign not in parentheses. So I'm going to go ahead and put it in parentheses, stating that is the factored form. That's as far as it can go as far as factoring. Okay. Can I factor x squared minus 9?
Yes.
What does that factor into?
X.
X plus 3 and x minus 3. What do we call that? Difference of squares. And then the denominator x plus 1. Can I factor that? Nope. So I'm going to put parentheses around it saying that I've checked it. It can't be factored. That's it. Okay, ready for the multiplying step? Remember this difficult step? Whew. That was rough. I know. Now, I can cancel anything on top with anything on bottom as long as it follows my rules. They have to be parentheses that match exactly, or something outside with something outside. So do I have parentheses top to bottom that match exactly?
No.
I have x plus 1 and x plus 1. What else?
X plus 3.
X plus 3 and x plus 3. Anything else?
No.
So, do I have anything on the bottom?
No.
No. So I have 2 on the top, and then x minus 3. I do not need to write anything on the bottom if there's nothing left there. Please do not multiply that out. Leave it in the factored form. If you multiply it to 2x minus 6, yes, that's easy, but there is the potential of you making a mistake in doing that on a test or a quiz. And if you multiply it out, not only have you gone an extra step, but if you make a mistake there, I then have to take off a point for that extra step because you did it incorrectly. So just leave it right there. Now, let's talk excluded values. There's no denominator, is there? So technically, there's no excluded values here, but there were denominators up there. I have to take those into account also. So, what value of x would have made this equal 0?
Minus 3.
Negative 3. That's my first excluded value, because if x was negative 3, I would have something over 0, and I can't have that as a part of my problem. What would my other excluded value have been? Negative 1, because I can't have that denominator equaling 0 either. Okay, so those are my excluded values. Please do not write your excluded values like this. What's the difference? This one is equals, this one is not equals. If you are excluding it, it cannot equal. This is a completely false statement if I just write equals. Okay? Questions there? All right. Division. Let's go up here. So we're going to start with a 5th grade division problem. Now, do you remember what we do when we divide? We never actually divide. We keep the first one, change division to multiplication, and then what do we do to the second one? Flip it. Now I can do my cross canceling if I want. 12 and 15 are both divisible by 3. That gives me 4 and 5. Can my 4s cancel? No, because they're both on top. Can 4 and 9 cancel? A lot of people at first thought think that cancels to 2 and 3. You can't square root, that's not canceling. So on the top I have 4 times 4, which is 16. On the bottom I have 9 times 5, which is 45. Now let's look at that for a minute. I don't know if that can reduce. It probably can't, because if it could, it would have reduced here. But if I encounter a fraction that I don't know if it can reduce, I want to show you how to check that on your calculator. Many of you have this calculator, and many of you are unaware that it can do fractions for you. Let your calculator do the hard stuff for you. There is a button right here that says A, B over C. If you have the Casio calculator that I've used before, the fraction button is easier to see. It actually looks like a fraction. But this is your fraction button. So if I wanted to type in 16 over 45, I type in 16 fraction for 45. And when I hit enter, it's going to give me the most reduced form of that fraction. If that's the most reduced form, that means that's as far as it can go. Okay? Let me show you that with something that we know reduces. If I typed in 100 over 45, now again, you have to use the fraction button, not the divided by sign. If I typed in 100 over, sorry, let's do 150, not 45. If I typed in 100 over 150, I know that reduces, right? I'm just showing a point here. If I hit enter, the calculator reduces it for me. Okay? So when you get to a test or a quiz, if you get something and you are unsure if it reduces, let your calculator figure it out for you. All right? Okay. Now let's get into rational functions, or rational expressions. So I'm going to take 7x over 2x minus 10, and that guy's got to stay as is. Then I change division to what? Multiplication. And the second one I flip upside down. So if you can multiply, you can divide. Right? All right, can I factor 7x? Nope, it's a monomial, can't do anything about it. Can I factor 2x minus 10?
Yes.
What can I do? Take out a 2 and I'm left with x minus 5. All right, can I factor x squared minus 11x plus 30? Don't know, I'd have to check, that's a snowflake. Remember the snowflake? 1 times 30 is 30. That's A times C. B is negative 11. It goes there. I need two numbers that multiply to get 30 and add to get negative 11. 5 and 6, and it looks like they both have to be negative. And then what goes up here? A is just 1. All right, so I have x minus 5 and x minus 6. And then can x squared minus 6x factor? Yes, I take out x, and I'm left with x minus 6. So far, so good? Okay. Later. Okay, so let's make our giant fraction here. And I can cancel top to bottom. What can I cancel? X minus 5. Okay. What else can I cancel? X minus 6. Anything else? I can cancel the x's because they're both outside parentheses, right? So what am I left with? 7 over 2. Huh. And I know that can't be reduced. So that ugliness all simplified down to this. Now, let's talk excluded values. Do I have any excluded values here? No, because there's no x's. But if I come back here, there are definitely excluded values from there, correct? So let's talk about that. 2x minus 10. Let's look at the factored form because that's the easiest place to find the excluded values. The factored form was 2 times x minus 5, right? What would an excluded value be from here? 5. So x cannot equal 5 because 5 minus 5 gives me 0. That makes that fraction no good. Now, looking here, my original denominator ended up not being a denominator, right? But let's find excluded values because since it was a denominator, I have to make sure that it was valid. Where is the factored form of this guy? Isn't it right here? So what would my excluded values be here? 5 and 6. I already have 5, so now I need to add 6 to my list. Are there any other denominators that I used in this problem that I have to find? This, because this now became a denominator. So looking at the factored form there, what's the excluded value here? 6 and there's an x in the front, which means that 0 is also an excluded value because that would be 0 times negative 6, that makes 0. So 6 was already on my list. There's my excluded values. Okay? All right, this last one, division. So I need to write the first one as is. And the second one, how do I flip it? It's not a fraction. I don't put it under 1, I put it over 1. That's what you meant, I know. So I changed my division to multiplication, and now this is going to flip, so it's going to be 1 over x squared plus 3x plus 9. Now we factor. X cubed minus 27. Oh crap. We have a difference of cubes. Remember that formula? Maybe, maybe not. A minus b, a squared plus ab plus b squared. So if this is what I'm trying to factor, what is a? Or what am I going to use in the a location here? X, because that's what, when you raise it to the third power, gets me that first term. What is b? 3, because 3 is what you raise to the third power to get 27. So now I'm just going to plug wherever I see an a, I'm going to plug in x. Wherever I see a b, I'm going to plug in a 3. So that leaves me with x minus 3. A squared would be x squared plus 3x plus b squared would be 9. Just so that you have it, in case you need a sum of cubes. Anyone remember the difference? First one is plus. Second one is a minus. Last one is always positive. Remember that soap thing? Same sign, opposite sign, always positive. I know I made a video for that one. All right, x plus 2, can I factor it? Nope, so I'm going to put it in parentheses saying I've checked it. That is as far as it can factor. Can I factor 1? Nope, nothing I can do with 1. And x to the third, or x to the second plus 3x plus 9. I'm not even going to check that one because, do you notice it's going to match this parentheses? Which means it's going to cancel. Now, if I checked it, just so you know, that one doesn't factor. You couldn't snowflake that one. It doesn't work out. But now when I do my multiplication, those two cancel. And what am I left with? X minus 3 over x plus 2. Now, do you notice I'm not writing parentheses there? You can write the parentheses if you want to, but just know that when you see it in the book, if there's only one thing there, just like this, they're not going to write the parentheses. Does that mean that I can go ahead and cancel these two x's? No, because even though I'm not writing the parentheses, they still technically are in parentheses. So if I want to do anything with them, I have to treat them like they're in parentheses. So I'm stuck right there. Now, excluded values for this one are pretty ugly. One excluded value is pretty easy. What would I get from there? X cannot equal -2. 1, no issue there, right? When I flip the fraction, I still have the x plus 2. That gives me the -2. The only way to get my excluded value from there is either to snowflake it or to use quadratic formula. I'm not going to use quadratic formula. I'm not going to give you one where you have to use quadratic formula to get rid of or to state the excluded values. Okay? So some of the problems may say state the excluded values. Some of them may not say that, especially when you get something like this. I'm not going to say state the excluded values because I don't want you to have to go through the quadratic formula here.
And it won't say that on the
Okay.
test.
Yeah, there will be different sections probably that say state the excluded values, or if it doesn't say that, don't do it. Okay? All right, turn the page really quick. I want to talk to you about this. On this page, this is simply another page of examples that are already done for you to see stuff. So if you get, let me step back. It's not the multiplication and division. These are all examples of after you've multiplied and divided, if your answer looks like this is how you simplify it. And this is how you would find your excluded values. So if after you've multiplied and divided, you get something that looks like this is how you cancel stuff. This is how you find your excluded values. Does that make sense? So it's different types of examples. There's one, if your answer looks like that, that's how you would simplify it. That's how you would state your excluded values, and so on and so forth. There is one that I would like to touch on, though. Let's see, if you have something that looks like that, that's how you would factor it and cancel and then state your excluded values. And then another one, but I think this is the same as the last one. Nope, slightly different. Plus to a minus right there. Okay, the type that I want to show you about is kind of like this guy right here. When you factor this, you get this right here. Do you see this? I'm going to write that down here so I have a little bit more room to talk about it. I have x minus 3, x minus 3. On the bottom I have 3 minus x and 3 plus x. Okay? Now, what can I cancel? Doesn't look like I can cancel anything, can I? Because is x minus 3 the same thing as 3 minus x? No, because subtraction, it matters what order you're writing it in, right? That's a positive x, that's a negative x, not the same thing. -3, +3, not the same thing. Now, when you have subtraction, and you have it backwards like that, we're going to do something a little funky with that. Bear with me. I'm going to take this 3 minus x, and I'm going to factor out a -1. What happens if I pull out a -1? -1 times what gives me +3? -3. And -1 times what gives me -x? +x. Now if I write the rest of the parentheses the way they are, x minus 3, x minus 3, 3 plus x. What do you notice about this? Isn't this now technically the same as this? It's a -3 and a +x.
Yeah.
So they can cancel out because this could be written as x minus 3. So what's the trick? If I have these opposites, I can cancel them out as long as I take out that -1. All right? So I'm left with x minus 3 on the top, 3 plus x on the bottom, and a -1 means I have a negative out in front of that fraction. Does that make sense? Sort of? Does the same thing happen with addition? If I have 3 plus x over x plus 3, do I need to take out a -1? No, because that's a positive 3 in both places, isn't it? And a positive x in both places. Addition, it doesn't matter which way you write it in. 3 plus 5 is the same thing as 5 plus 3. It's only subtraction, because subtraction, when you reverse the order, you change the problem. So those ones could just cancel straight up, right? Because they would be in parentheses. Okay? So just be aware of that. If you have that minus thing, you might need to look here, and you can cancel the opposites if you put a -1 in there to replace it. Okay? All right, there you have it. Your homework is out of the textbook.